Here's an introduction to Gauss Law. And this is really a high-level overview of the ideas that you'll learn in this section. So one of the first ideas is the idea of flux. And this is brand new to people. So flux gets the symbol phi, and it's defined by an integral. And it'll, again, go into many more details in a specific section just on flux. But this gives you a basic understanding. And that's one of the sort of weird things that we have to get past, and so that we can move on with Gauss Law. And this ties in directly to the main event, which is, of course, Gauss Law. Now, in some special conditions, when you have a constant uniform electric field and when you have a planar area, then the calculation for flux, or the integral, simplifies to E dot A as a dot product. Gauss Law, again, that's the main event here, so I'll give that a double circle. It really ties in the idea that if you define something called a Gaussian surface, then within that Gaussian surface, the enclosed charge, so I'm calling that Q in because it's inside the surface, is that when you divide that by something called the permittivity constant, which we just saw in the previous lecture, is equal to the flux through that Gaussian surface. Then there are applications of Gauss Law. So you can look at a sphere, we will look at a cylinder, and we can look at a plane. And to top it off, we finish off with 3 key ideas about conductors in electrostatic equilibrium.